Okay, basically this session, I'm thinking because David just added this to the class design. He just decided to have a review session every week
Mhm.
on the Sunday. So we will have a 2 to 3 hours review session, and it's kind of flexible. So for this week, I'm gonna mainly talk about this rule because
Yeah.
I have many students ask me about this question. So also for this session, I have select about 6 questions. They're all they look same but slightly different because last time you told me that so you know what the rules are but you just couldn't apply it to different situations, right? Like
Yeah.
for example, for this one we have the direction like this, but for this one the direction is slightly different. So I have
Yeah.
all of them. They all have some trivial differences. So I'm thinking that we can practice it.
Okay. Sounds good.
Um, let me see. Do you want me to? Okay, since I'm recording this, just let me introduce this briefly because it probably more students want to check the recording out. So first let's check this rule. So still, the first rule is sum all the currents up, right? So we could just apply it to this question. The first rule is about hmm? One more student. Hello. Hello, Anna, can you hear me?
Yeah, I can hear you.
Okay, we just started. So let me introduce this to you again. So for this review session, it is supposed to be 2 to 3 hours, but since this is only the first week and the review session is kind of flexible, so for this week I decided to only talk about these rules. And today I have 6 questions. They all related to these rules, and they are all slightly different. So I'm thinking that we could solve them together. So you could, you know, how to apply this method to different questions because all of them they all a little bit different. The question itself are all same, but the figure is a little bit different. Like for this one, the direction of the power is kind of different with this one. Yeah, so that is what we're going to do today. All right. So also I'm thinking that since we have 6 of them, so I'm thinking that I'm gonna show you how to solve them for first 4 questions, and for the last 2, like we could solve it together, and so I wouldn't like talking while I'm solving it. So we can solve it together, and at the end we can cross check our answers so you know if you really know how to solve it. Because sometimes when you watch someone else solve it and you're not actually know how to solve it yourself, right? So yeah, let's start right away. So from the first question, we for the question we also check review the rule itself. So the rule consists of 2 parts, the first rule and the second rule, right? So the basis is the first rule. The basis is that the sum of all the currents entering any junction point equals the sum of all the currents leaving the junction point. So this is the first step we're going to do. We're going to decide the current, right? Because why would we do this? So for this kind of circuit, we have uh more than one power, right? So we don't know what is the direction of the current. So like if we only have one power, the direction is gonna be like this, right? From this point to this point. But since we have 2, we don't know if we how to say that if we only look at this the direction is like this, right? But if we only look at this, the direction is like this. So we don't know. We cannot decide what is the direction. So we need to take a guess. We need to take a guess how where the current would go. So at this step, this just guessing. We randomly choose the direction. I2. So this is just my I'm always choose the current to be like this, but it's not always like this. You could choose it like this, right? You could also set it like this. It doesn't matter because this is just a guess. You could guess it goes from upside to downside. You could guess it go from here to here. It doesn't matter. This is all just guessing. We suppose it go like this, and then since we already take the guess that the direction of the current is like this, so we also believe what? We also believe the electrical potential. We also make the guessing on electrical potential because we know the current is always go from where has higher electrical potential to where has lower electrical potential. So at this step, we should also mark the electrical potential here, just like Brahmia did, right? So we have here is higher, here is lower, here is higher, here is lower, here is higher, here is lower, right? Because at this step, we basically have everything we need to have for rule 1. So at this step, all the electrical potential, all the direction of current, they're just guessing. They're not. They could be true, they could be false, but it doesn't matter. And after we have this, so we can move to second rule. This is the complex part. It says the sum of all the gains and the losses of potential around any closed path must be 0. So this is the rule. We can use this rule derive 2 equations because we have 3 unknown variable here, right? We have I1, we have I2, we have I3, and we are looking for I3, right? So from the first rule, we have I3 equals I1 plus I2, right? So this is the first equation we have, and we still need 2 more. Why? Because we only want 1 unknown variable, which is I3. So we need 2 more, so we can substitute.
That's a question.
Okay.
So could have also said I1 equals I2 plus I3 or no?
You mean based on my setting?
Yeah, like the equation you just said, it says I3 equals I1 plus I2. Could it have also been I1 equals I2 plus I3?
Oh no, you cannot do that because for first rule it says all the currents entering any junction point equals the sum of all the current leaving. So my setting up is that this is the junction point, and the only current entering this junction point is I3. So we need to put all the currents entering the junction point at one side and all the current leaving that junction point at another side.
Okay, that makes sense.
Yeah, so if based on your you said if we can do I1 equals I2 plus I3, if you want to use this equation, you need to set it as like this, right? Based on this setup, here is the junction point, and you have I1 as the one that entering the junction point, and I2 and I3 as the 2 leaving the junction point. Yeah. So this is the rule 1. So then we look at rule 2. We need to have 2 closed path. Yeah, and this path usually I would just choose this 2 to be clockwise, but it still doesn't matter. You could choose it as counterclockwise, clockwise, and it could be all have the same direction or have different direction. You could also choose it. I always have 2 small circle, but you could also have this as your circle. It doesn't really matter because all we want is the equation, because we need to have the equation to substitute them to the third equation and cancel out the variables that we don't want. So here we have these 2. Also, I will also show you that the direction doesn't matter. So first, let's just write this circle 1 down. It has, oh, okay. I noticed that some of you send your work to me. I noticed that you start to decide if it is a gain or loss at this step. Usually I would just write every component of the path down at this point. I wouldn't decide if they're gain or loss because it looks it's just a redundancy. But I think it's really important to write all the components down and then substitute the numbers into it. Because if you just start to how to say that, decide if it's a gain or loss, you probably, if you made a mistake, you have to start over again, start from the very beginning to check, oh, where did I where did the mistakes happen. But if you have everything here, you just need to check all the equations you have derived, and you could just check, oh, are all the equations are right? If they're right, oh, that must be the math part, right? It's not because I have used the method in the wrong way. So I think it's pretty important. Also, like when we were taking physics 1, right? Professor Brachmier always write down when he was doing the free body diagram, he always write down everything. Like what is the x has, what y has. He always write down everything. It looks like it's just a waste of time, but it actually can give you the clear answer, logic, right? So I'm thinking that maybe we should just write everything down and then to analyze it. So for the first circle, we have 1, 2, 3. Oh, did I? Oh no, this is not. This is I1 and R1, right? This is for the first circle. So now let's decide if they're gain or loss. So for let's check this side, nothing, and this side we go from lower to higher, right? Because from lower to higher, it's just like you're at the floor 2, you're going to floor 5, you're going upstairs, so you actually gain like that. So it's a gain, so it is positive. So we have 16 here. And then we look R1, still from lower side to higher side. So we have plus R1 is 1, so plus I1. Then no, not plus. Then let's check this side. It's from lower to higher. So we still have a plus, right? It's plus 2.8 I3 equals 0. So now we have our second equation. So this is the first one, and now this is the second one. Second one, let's simplify it. Not really simplify. Just write the constant to another side. This is the second equation we have. And then we have, okay, another point I want to bring up is that in my video on my YouTube channel, I said that at the very end, I said that if you have your current to be negative, that means at the first step, the direction of the current you choose is wrong. Although it doesn't matter if it's wrong or right, because when we write it in the answer, we only took the numerical part. We don't take the sign part. But someone asked me if a student has her notes. here say that this is wrong direction. So it doesn't work in this way, because at this point, I1 and I2, I3, we don't know which one is wrong. We don't know if they both negative, or one of it is negative, one of it is positive. We don't know who caused this negative number. So we need to analyze it at the very end. And also, this part is not like, why would we need to know what does this sign mean? It only gives you, like when we're in exam, right? It's really easy to go crazy thinking about why my current is negative. Can it be negative? If it's in homework, you probably can like rationally think about it, be like, it could be negative. But if you're in exam, you could just get panic, like, oh my god, why am I having a negative answer? Should I redo it again? So this just lets you know that the current could be negative. The negative sign is just used to denote the direction. All right. So at this point, we don't know which one is wrong, because they could all be wrong. All right. So next we have our third equation. We have, for second circle, still we write down all the components. We have V2 plus I2 R2 plus I3 R3. Then we again check the gain and the loss. We have this side nothing, this side this side we go from higher to lower. So higher to lower, it is a loss, because like we'll go from floor 5 to floor 2. We go downstairs. So it's just like forget about it. We just go from floor 5 to floor 2. We go downstairs, so it's a loss. So V2 should be negative, right? So now we write negative 23. And then we check R2. R2 is also this current go this way, right? Because then we have I2 be like this. So look at R2, we have a loss, right? Still we go from higher to lower. It's still a loss, so it's still minus 1.6 I2, and then R3 still a loss. So we have two. Yeah, you have a
I
question?
have a quick question. Yeah. So wait, I thought we don't assign direction at this step yet, or are you just doing it for the second equation?
Oh, you mean the I2 here?
No, in general, because earlier you said just to like write down all the variables first.
Mhm.
So like I thought we don't assign the magnitude yet. I might have just misheard you. Just making sure.
At this, I was saying that at this step we don't assign if they're
Oh, okay.
we don't decide if they're a plus or minus, because we just
Okay,
want to
okay.
write everything down. Because I have made a mistake that for this kind of question I always miss out V3. So this is kind of help you that don't miss out any power or resistor.
Understood. Okay, thank you.
So here we have I3 equals 0. So are they all loss? Yeah, they're all from higher to lower, right? So still we move everything to one side. It is 1.6. We move all the variables to one side, plus 2.8. I3 equals negative 23. Okay, this step is also the step that we always have the chance to make mistake, because the sign would change from negative to positive. So for this part, we still need to be very careful and check it again. Okay, this positive, yeah. Okay, now we have everything we need, and now just need to write them down all together. The two rules are actually just help us to derive these three equations. So then the following part are all just math. So the following part, as long as we've been very careful, we can always get the right answer, I think. Let's check it again. Yeah, so first we substitute. Also, for this question, I don't know if I remember that when we were in like elementary school or middle school, we have some trick that can like substitute them, cancel out them each other in a real quick way. But I always like mess it up. So at the end, I just decided to use the most, how is that, lazy way, just substitute, like write the variable at one side and everything to another side, even though it's kind of complicated, but it's safe. So let's see. First, we substitute 1 to 2 in order to cancel out I3, right? So we have I1 plus 2.8 R1 plus 2.8 I2 equals negative 16, right? Also this step, I sometimes write it to equals 0. So also be very careful for the math part. And then we substitute 1 to the equation 3. We have, they're saying 2.8 I1 plus 2.8 I2 equals negative 23. So now we only have two unknown variable here. So we're one step closer to the final answer. So now we moved here, simplify it a little bit. We have 3.8 I1 plus 2.8 I2 equals negative 16. Right, check it again, yeah. And then next step we have 2.8 I1 plus 4.4 I2 equals negative 23, right? Let's just make sure. Has a calculator. Even though it just summed them up. Okay, 1.6 plus 2.8, 4.4, yeah. And then we substitute, let's see, equation 4 to equation 5. So from 4 we have, now, wait, I made this mistake. Okay, I should be more careful. All right. So do you know what is wrong with my solution? Have you noticed it? What's going on here? Where did I, like, what's wrong with this solution?
Is it you're using 1.6? Oh wait, is it? Oh, I don't know. I'm trying to do it by myself, and then I'm a few steps behind you.
Oh, okay. You don't have to start to like work it with me, because I will, like, for the last questions we can just solve it together. So I wouldn't talk. We just solve it together and then we cross check each other's answers. But still, okay. So you guys haven't noticed what's wrong with this solution? I'm already at a dead end. I have to like turn around, drive out of this dead end.
How do you know it's a dead end?
Yeah. Because this question, it asks for I3. I already canceled out I3. I shouldn't do this. Oh my god, you guys should be very careful about this. This is just, I have to erase off this because I canceled out my final answer at the first step. So I shouldn't. These are all wrong. They're not like
Because then that
technically
would mean you wouldn't be able to find it either way, right? Because then that would mean you'd have to find I2 and then I1 to find I3 at the end.
Yeah, that's okay. I still can find the I3 by I1 and I2. I could derive it from this, but it takes you more time because you have to like substitute I1 and I2 back to equation I2 and I3, back to equation 2 and 3. So we better be very careful when we still at this step, because that, how to say that, because exam is timed, right? We don't want to make any mistakes like this. Also, in the exam, you could be panic at any moment that, how to say that, if the math gets too complicated, sometimes we lost in it. So I better rewrite this to be, it can be anything. I just write I1 at one side, all right? I3 minus I1, I2. Yeah. And then again, okay, let me quickly write them down. So it's I2 plus, nope. Okay, let's check this out. Yeah, that's right. And then, since we are looking for I3, the math is kind of easier when we are looking for I1 and I2. It's much easier. So it's negative I2 plus 3.8 I3 equals negative 16. And then 1.6 I2 plus, this is much easier. So now let's derive the variable I2 from steps, equation 6. We have I2 equals 3.8 I3 over 16.
Wait, what are 6 and 7?
6 or 7, we simplified equation 4 and equation 5. So 4 to 6, 5 to 7.
So basically, like once you create the equations on the left-hand side, where you numbered 1 and 2, and you assigned their direction, you just start to basically simplify and combine everything to cancel out and solve for the variable you're looking for, right?
Yes.
Okay.
Yeah.
Got it.
Okay.
Sorry, I'm still a little lost because I see that 5 to 7, 5 remained the same. It didn't change.
Yeah.
And
Yes.
from 4 to 6, what is the change?
Yeah, that's why I said that when we're looking I3, it is actually easier, because for equation 3, like, because we're looking.
You just combined the 2.8 I3 plus the 1 I3. Okay, I'm sorry.
Yes.
I just realized. Okay, sorry.
Okay, so now we have equation 6, and we already derived the most useful part, which is I2. I2 is this term, so we now substitute 6 to 7. It becomes, it is actually I3 times 16, right? Yeah, n plus 2.8 I3 equals negative 26, 23. Yeah, okay, next. Calculator. Okay, if it were in exam, this could be simplified further, because for this first equation, you could just have it, you could just write that as 3.8 over 10, right? The same thing. But since we have time, we could write a complete term. All right, final step, we finally have the answer is okay. This is my final answer. Since it's negative, so we know our guess is wrong. So I3 is not from downside to upside. It is actually from upside to downside. Are we having the same answer? So if you guys have your answer, just let me know. Okay, I will wait.
Wait, can you explain again what you did with 6 and 7?
Oh, what I did here, I have I2 at one side. I derived this term from this equation.
Oh, you defined I2, and then you just plugged that into 7, and then you solved for I3.
Wait, did I? Oh, wait, this is wrong. Oh my god. Okay, this is not the right answer. Let me see. This is wrong. It's not fraction. It's actually let me think. It's 16 times 3.8 I3, right?
Times or plus?
Oh, plus.
Okay, just making sure.
I think it's minus. Oh, I the negative side.
And now I need to substitute 6 to 7.
Yeah, that's what I got.
Ashley. Hi, Ashley. Can you hear me? Okay. Have you received my email? I said that we're going to discuss these rules. This is a very hands-on review session. So basically, we're just solving problems. I have six. I have six different questions related to this method. So we're working on the first one. So we still have 5 questions left. So yeah, now we're waiting for George to finish his answer. So next question we could all work together.
Okay, so I also got 5.4, but in what case? Because I remember when we were doing this during the week, like I got a negative value as well. So like, is that just because of the math, or at any point do you just assume that it's positive, if that makes sense?
You have the answer without the negative sign, right?
Yeah.
Are we have the same setup, or are we have the different direction? Are you using counterclockwise?
Yeah, no, I'm doing the same thing. It's probably just somewhere when it came to one of my numbers, I just probably forgot to plug in the magnitude.
Yeah, if we have like the exactly same setup, it must be the math. But if we have different direction, it could be positive.
Oh, okay, got it, got it.
Okay, so now let's move to the next question. It is a little bit. This is question 9 from homework. So this question is kind of a little bit complicated, more than question 2, but only one. We have one more power here, but still same thing. We just apply these 2 rules into this question, right? So no matter how many powers it gives us, we could just treat it as a ordinary component. So still we since Ashley just come in, so we can let's review this again. So first, for this rule, this is just a method that I use to solve complex circuits, which includes several batteries that cannot be simplified. So usually in exam or homework, we have a question like this. It has a figure. So the main part of this kind of question must be analyze the figure, right? If the figure only has one power, it must be simplifying it. But if it has several powers, it must be using these rules. So yeah, just to look at this figure could help us to quickly um, locate the formula or method in our notes or formula sheet. So since it has 3 powers, we're going to use this rule. So let's start from the rule 1. Rule 1 here, we have the sum of all the currents entering any junction point equals the sum of all the currents leaving the junction point. So still, if you want to solve this like at the same time with me, you could have different setup. You don't need to have the exact same setup like mine. You could have yours, so we can cross check our answers at the end. So we can like if we answer a difference, you could revise mine. I could revise yours. All right. So also, I'm just gonna use this at this step. At first rule, this step, since it has multiple power, we cannot decide what is the direction of the current. We cannot like if a current is like this, we know the if the circuit look like this, we know the current is gonna come out from this side, right? It's gonna go this way. But since we have 3 powers, we don't know. It could be like this. But what about this power? If we just check this power, the current could be go this way, right? We don't know. So we just take a guess. We take a guess, okay, we guess for R3, the currents go this way. we guess for R2, it'll probably go this way. We don't know. We just take a guess. All right. So this the guessing I have. And also, when we decide the direction of the current, we also decide the electrical potential. So we know the current is driven by the power, that is driven by electrical potential, right? From higher to lower. So when we have this direction, when we have this three direction, we also have the electrical potential, right? We should mark it right now because later on it's probably gonna confuse us. So now we have, yeah. So now we can derive the first equation we're gonna use here, right? Because based on the first rule, we have all currents entering the same junction point is equals to the sum of all the currents leaving the junction point. So I3 is the one that entering the point, and I1 and I2 are the two that leaving the junction point. And every currents entering not every, the sum of the currents entering this junction point at one side and the left of them at another side, right? So we have I3 equals I1 plus I2. This is the first equation we're gonna use later on. This is the okay. Now we move to second rule. Second rule is the sum of all the gains and the loss of potential around any closed path must be zero. So here we talk about electrical potential. That's why we want to mark the electrical potential at the first step, right? Because we're going to use our guessing to decide if it is a gain or loss. So here we can around any closed path. So we have two. Okay, this direction is also what I'm used to do. I always draw them as clockwise. You could use counterclockwise, and you don't have to have two small circles. You could have one small circle here. You could have another circle like this. Doesn't matter because at the end we just want three equations because we have three unknown variables. We need to cancel out two of three unknown variables. So we need three equations. All right. So now we have everything we need. We just need to derive the two equations. Let's look at circle 1. Let's first write down all the components in case we miss out any of them. So we have V1, we have R1, R3, V3 equals 0, right? We have 4 parts. Yeah. And then this step we start to analyze if it is a gain or loss. So here we look at V1. Wait, let me mark this. Here we have V1. V1, is it gain or loss? It is loss, right? Because we go from higher electrical potential to lower. Just like I just said, it's like you go downstairs. You go from floor 10 to floor 2. You go downstairs. So since it's a loss, we have V1 to be negative. So we have minus 14, right? And then next we check R1. R1 we decide the Okay, also at this step, we don't look at this arrow. All right, this arrow just used to why we draw this arrow, because we want to mark the electric potential. After we mark the electric potential, the direction of this arrow doesn't matter now. Now we only look at this circle. All right, so from the step 1, we have electric potential. From step 2, we analyze the electric potential. This direction, we only use it to mark the electric potential. All right, so now we have this circle to be clockwise. So here it is a gain, right? From lower to higher, it's a gain, so we have plus. And then we look at R3. R3 again, right? Still from lower to higher, you go upstairs, it's a gain, you have plus. Okay, last one, V3. We go from negative side to positive side, it's a gain. Still plus V3 plus 14 equals 0. So let's simplify it a bit. It's V1 equals V3. Okay, this number is interesting. So we don't have right hand side. The right hand side is 0. So that's the second equation we have here, right? This is the second equation we have. Okay, now only the last one left. We look at, okay, since I recorded this, let me show you why the direction you choose of this circle doesn't matter. All right, so let's see if we have circle 3. Circle 3 is counterclockwise, right? But still, we're still gonna have this equation. Why? Because, okay, let's check. Still, V1 plus I1 R1 plus I3 R3 plus V3 equals 0, right? And then we look at V1. So V1, since we have it counterclockwise, right? So V1 now is a gain. It's 14, not minus 14, right? It's 14. Then plus. Since now we go this way, so it's from higher to lower. So now we need to minus R1, right? So now it's my, wait, why would I minus? So it's minus 1.8 I1. And then we check R3. R3 now, again, it's from higher to lower, right? From higher to lower. Because now we draw it in counterclockwise. It's from higher to lower. So now it's negative now. It's minus 2.9 I3. And then we look at the final component, the V3. And this time we go from positive side to negative side. So now this time V3 is a loss. All right, so now V3 is a loss. We have minus 14. Again, let's simplify this. So 14 minus 14 equals 0. And then we have negative 1.8 I1 and negative 2.9 I3. So it is still the same equation like we just derived.
Wait, so can you just say again, like what you're showing with the gray equations?
Oh, I
I
just
see that you
want,
wrote number 3.
yeah, I just want to show you that it doesn't matter which direction I choose for, you choose for the closer path, because at the end, no matter you choose it clockwise or counterclockwise, it will always end up to the same equation.
even if that goes against like the original, well, what you chose the current direction to be.
You mean even though if the green or gray against the purple direction? Or you mean
Yeah, that's what I meant.
oh, the purple one? Yeah, like I just said, the purple one. I could just erase the purple one here because the purple arrow that is useless now. We don't need it now. Why would we have this arrow? We use it to denote the direction of the current, right? But why would we want to know the direction of the current?
Because
We want,
technically we don't know it at this point.
yeah, we don't know, and we have this direction, right? It's a guessing, and then we use the current direction of the current to decide which side has higher electric potential. So for this direction, this side is higher, this side is lower, right? So why would we need electric potential? Because we're going to use the second rule. In the second rule, we need to decide if it's a gain or loss using electric potential. So at the second point, at the second rule, at this point, we don't need to know the direction at all because we already have the potential. We already have the product of the direction of the current. Does that make sense?
Yeah, it does.
Yeah. So at this step, we're not talking about direction now. We're only talking about electric potential. So even though like they're against each other, it doesn't matter. So you can choose it go anyway. It doesn't matter. Yeah. So direction is not the factor that is gonna prevent you from the right answer. So now we know that direction doesn't matter. We can always have the exact same equation 2. Where is it? Yeah. But also it could be different. If you choose the circuit to be like this, the equation 2 is definitely going to be different, right? Because the components are different. But if as long as your components are V1, V3, R1, R3, you're definitely going to have the same equation. But if you have the circuit this large, if it contains V1, R1, R3, V2, the equation would be different, right? But if we in this little circle, they're always going to be the same. So let's back to the our original track. Now we look at circle 2. We have, it seems they're all the laws. V2, higher to lower, it's a loss. Oh, let me write them down. Of them down in case I left anyone behind. It is everything V2, V3, R3, R2. Yeah. So let's check our V2. It's a loss. Let's check V3. Loss. Let's check R3. Okay, look at this. Look at here. If I like erase this part, you still can check. You still know if R3 is a gain or loss, right? Because we already have the electric potential. It's from higher to lower. We still can know it's minus, right? It's minus 2.9 I3, right? And then we have R2 still lost. So it's 1.6 I2 equals 0, right? Yeah, so now let's simplify it. Simplify it to 1.6, move this term to right hand side, then move 1.9 I3 to right hand side, and left negative 20 minus 14 is negative 34. yeah, this is the third equation we have. Okay, we're gonna use the three equations in the green box to do the final math steps. So now let's write them all together. Equation 1. Okay, let me write this real quick. Okay, let's check again if everything is compatible. Yeah, it seems right here. So now let's substitute 1 to equation 2. We have 1 point A and also 1 to equation 3, right? So we want to cancel out I3 because we only want I1 left. So we have 1 point A I1 plus 2.9 I1 plus 2.9 I2 equals 0. We have 1.6 I2 plus 2.9 I1 plus 2.9 I2 equals 0. Now we already cancel out I3, right? So now simplify it further. We have 4.7. Yes, now we have equation 4 and equation 5. Only two unknown variable left. We now we're going to derive R2. So we can use equation 4. We have R2 equals negative 4.7 I1 over 2.9. It's 6, so we substitute 6 to 5. We have, okay, let's go here. So we have, we substitute 6 to 5. We have 2.9 I1 plus, minus. Okay, something goes wrong here. Oh yeah, I made this mistake. Oh my god. Okay, this mistake is super common. I forgot the right hand side. I just write down equals 0, which is not the truth. Because equation 3 equals negative 34. Okay, so at the end, if you have something like this, if you find your current equal to 0, it's wrong. You need to go back, check your equation, see where did you make the mistake. And here I left the negative 34. Right, let me think. Yeah, so it's about okay. Let me check what is my answer. It's negative 7.3 over 2.9. Not over, minus 2.9, and then negative over. We have different. Oh no, it's not. It's plus. Okay, kind of similar. I also have 7.773. So we have the same answer. Write down 7.73. Okay, no problem. See you next week. Bye. Okay, I will. Okay, oh, she left. All right. 7.73. Okay, so next. For this question, how about this? So we all use different like setup, and I wouldn't talk why I'm solving it. So at the end we can cross check our answer. How about that? So we have different setup. We can practice when we have different situations.
Okay, that works.
Okay. Oh, only you and me. Okay. So
Yeah.
are you familiar with this kind of questions?
Yeah, I wasn't getting them before, but I've been doing them on my own. Like I did the number 9, the one that we just did, or number whatever that was, and I was getting it. Like I did it, I got it right. So
How what about this? So since I think nobody would come again. So how about this? We solve this this question together, and if we still have the same answers, which means you totally get how to solve this kind of question, so we could just move on
okay.
and end this review session. So if you have any other question, like it's not about this matter or any other homework questions, we could talk it further. How about this?
Okay.
Okay, so let's solve it together.
Okay, I'm at the last part. I just have to solve for I2 now.
Okay, sure.
Okay, yeah, that's exactly what I got.
Okay, cool. Let's end this topic. Do you have any other questions about the homework we have so far?
I think there was one question that let me go back and check. That I kept getting wrong, and let me log in because I know I didn't get it right. I couldn't figure out what I was doing wrong.
Is it in homework 3 or homework 4?
It was from the very last homework. So it was homework 4. Oh, yeah, it was homework number 6. Do you want me to send you a picture?
Wait, homework 4, question 6.
Yeah, it was homework. Sorry, it was homework 4, question 6.
Is it this question?
Yeah.
This question. Let me think. Are we having the? Are we already have the same figure?
Yes.
But which resistor your question is asking?
I was supposed to be looking for resistor 4.
Resistor 4. This kind of question is kind of tricky. Just like I said in the video, you could be very lost until you find it. Let me think.
Because I did this homework with 2 different tutors, and I thought I was getting it, but then from like once I turned it in, I wasn't getting it correctly. Because like the logic that I was given was, since there's like if you get R equivalent for the top and the bottom like as parallels, then you could basically ignore the bottom tier and just work on the top half of the circuit where
Yes.
R4 and R5 and R6 are. And I basically only had to get R equivalent for the top. And then after that, I find the total current. And then
Hold up. How do you find the total current?
I would use the voltage, which in your case, I guess it was 20, mine was 12, and then I would divide that by R equivalent of the top half of the circuit.
Okay, that's where the problem at. So when you analyze this part, you could like if we're only talking about the voltage, you could only look at this part. Why? Because I don't know if you watch my video. Do you know this trick?
Use divide, parallel divide. No.
Okay,
I haven't watched your video, no.
Oh, okay. So I've made my video. So I've made the video for every single questions which you count. Oh, not this. For my section, the video is I would upload my video on the homework prior to the deadline of your homework. So if you really don't know how to solve it, you could just check out my video. So
I didn't know this was up there.
Yeah, it's divided based on the question. So if you only don't know how to solve question 6, you could just go check that question out. Yeah, because my section is asynchronous, so we don't like actually meet. So also okay, let me just introduce you this trick. So this trick is from my high school. So this trick is kind of weird because it doesn't have a rhyme because I translated from Chinese. This is from my high school teacher. So So what's going on here? If you have the formula sheet, do we have it? Okay, no. So in the formula sheet, it doesn't. This is not given, right? It is in parallel, but this two equation is not given. So if you're in the exam, although we're having open book, so you can always Google it. But to save time, right? So I have this two trick. This can help you to analyze the circuit. So what does this mean? I didn't make this up. This trick is based on this two equation. All right. So this trick says series divide voltage, which means if the two components, it could be the two resistors. If two resistors they're in series, they divide the voltage. So
which means they don't have the same voltage.
They don't have the same voltage. So this part and this part, they're in series, right? So they don't have the same voltage. But right. We're not saying that series divide current. So they're in series, so their current is the same. And here say the parallel divide the current. So even though the current path entering here, leaving here, is the same as the current entering here, leaving here, but the current entering here is different than the current entering here. Because these two, they're in parallel. They divide the current.
Okay.
Yeah, so this two sentence could help you to analyze it quick, but you can always use this equation, right? This equation also intuitive, but I think my trick is better. I started using this from my 7th grade, so I think it's pretty useful. So we can practice these tricks. So as you just said, when you have the total current, you use this V, right? And divided by the equivalent resistance here, right?
Yeah.
But that's not the case. Why? Because parallel divide the current. This two part is in parallel, so the current entering them is different. And here, the current is divided.
Oh.
Yeah. So when you.
But even so, like, so what does that even mean? So if like the numbers that I plug in, like the total current, the total voltage over the R equivalent of the top circuit, that answer, is that just totally incorrect, or does that only give me the current of the top?
Like for example, this is your okay, mark this as I1, mark this as I2, and mark this as this is total I. So you're using V over I2, but you're supposed to use V over I1 plus I2, which is V over I.
But I use V over R, not I.
Oh, no, yeah. Oops. Okay, it's you're using when you let's write this. Actually, V over R 456, right? This is the equivalent resistance. This is actually equals I2.
Right.
And then you have I2, and you want to know. Oh, you already have the answer. So the P2 is actually V2 square times R.
I'm looking for R4, like the power in 4. So then that would be P4 would equal I2 times I4. But then I did that. What did I do? Okay. Because then, you know what I used? I didn't use that equation. I didn't use the I2 R4. I used the V squared over R.
V squared over R. Which V you're using? Are you using the original power? Oh yeah, that's the problem. Yeah, that's a problem. Here we say the series divide the voltage, right? So they are in series. So the voltage between these 2 points is different from the voltage between these 2 points.
But isn't technically, because I was told, like, if you divide the voltage and then you mark one side as 20 and the other side as 0, all of those parallel should have the same voltage.
Yeah, that's right. Here we have 20. Here we have 0, right?
Yeah, and isn't
And
that the case if you keep going up and up and up?
20, 0. 20, 0. Okay, now things get changed. V4 and V5, 6, they're different.
Oh gosh. Okay. Yeah, I see. So R4 doesn't get all of the voltage. Yeah, that's why it doesn't make, that's why it's wrong. Okay. See, you know what my biggest problem is? Like I have a hard time like determining which V am I using. Like do I use R equivalent or do I use the total V? Like you know what I mean? Because like each one, like in a circuit, each equation has its own, like it could either be for one resistor or it could be equivalent.
Yeah, this kind of question, every question about the simplifying circuit is super confusing. Like when I'm solving this problem, I probably need to go here. Probably already at the very end, I finally realized, oh, I can use this equation. Because like when we talk about your case, when I write down this, I know, oh, I can use this equation. But before you told me you're using V equals over R, I need to like, how to say that? For this kind of question, you need to derive everything you can.
Mm-hmm.
If you probably want to simplify everything and have all I1, I2, I3 all in your hand, and then you look at them and pick the useful ones that can actually have the final answer. You could be very lost in this kind of question. I totally understand.
It makes more sense like if you actually draw it out. Like that actually helped me visualize like what I was doing wrong. So thank you.
Okay, guys, since nobody is gonna enter in this review session, I'm gonna end it now and see you guys next week. All right.